All right, welcome back to part 3. So we're going to do number 5 first. Now, remember that the identity that we want to use is that the limit as u goes to 0 of sine of u over u happens to equal 1. Now, in this case, I have two terms. Both are squared, but both involve signs. So I want to do some sort of manipulations on them to get it here. One thing that I'm pulling out is that since the signs of squares, we can kind of think of it as something like a sine of 4x times a sine of 4x. And we can do the very same thing for the bottom, but in this case, we'll expand this so that it looks something like this. Sine of 3x times 1 over sine of 3x. And then this is going to be equal to the limit as x goes to 0. Now, if I were to naively plug in this limit, I would end up getting some sort of 0 times 0 times 1 over 0 times 1 over 0, which, if you just kind of concatenated everything, would look like 0 over 0, which to us is an indeterminate form. So what I want to do is I want to match this limit identity that we have up here to down here. Now, for each of these cases, we'll have our own individual u. So for this first term right here, this will be our u. So I need to multiply top and bottom by the same factor, in this case 4x, so that it matches up with the identity. So I'm going to take this front term, I'm going to multiply it by 4x, and then I'm also going to multiply the bottom by 4x. I can just write 4x in for here, because 4x times 1 is just itself 4x. And then I'm going to do the same process for this term. In this case, u would be this 4x, and so I could multiply this term right here by 4x times 4x. Over here, when we have 1 divided by sine of 3x, this will be our u. So our u is going to be 3x. So once again, I want to multiply top and bottom by 3x. So 3x up top, 3x down bottom. Again, same thing over here. And now I have a bunch of terms that look very similar to the identity rule that I have here. So this will be a term right here. This will be a term right here. This will be a term right here. And then this will be a term right here. Now, there's a little addition parts where I have these 4x's which don't kind of belong. So what I'm going to do is I'm just going to take all those parts that don't belong and just concatenate them together. So I'll have something like the limit of x goes to 0. I'll have one 4x. I'll have this other 4x over here. I'll have this 3x from this. And then from here, I'll also have another 3x. And now I'm going to take each one of these terms and kind of write it. So I'll have something like sine of 4x over 4x times sine of 4x over 4x times 3x over sine of 3x times 3x over sine of 3x. Now, while I've changed how these terms look like, I haven't fundamentally changed what the algebra is, because all I've done is manipulations where I've had some sort of like fraction over fraction. So I have like 3 over 3, something like that. Any multiple by 1 would equal itself. So for instance, if I have x and I times it by 1, it's just itself. This is kind of the rules that I'm going to do to manipulate all these terms. Now that I have these things over here, I can treat this term as here, the collection, and I can start doing reductions. Now, in each of these cases, I have an x, so I can just kind of cross these out. I also have an x here. I can cross these out. And now this will become a constant term. So 4 times 4 is 16, 3 times 3 is 9. And then I can pull that out in front of the limit by our limit laws. And then this limit here will then be able to distribute to this term, to this term, to this term, to this term. And now we can really start to use this identity. So if I go ahead and rearrange that, it's now 16 over 9 times the limit, as in this case we'll have it u goes to 0 of, in this case, this is going to be our u1. So I can, u1 goes to 0 of sine of u1 over u1 times the limit of u2 goes to 0 sine of u2 over u2 times, and I'm going to run out of room real fast here, limit as u3 goes to 0 of u over u3 over sine of u3, and then one last multiple over here because I've run out of room is u4 goes to 0 of u4 over sine of u4. Now I have a bunch of indices, but really I haven't changed what this term looks like, where it's sine of something divided by something. So in this case where I see these u1s, I can now just treat them like this identity. So in that case, this term right here is going to get a 1. This will also go to 1. This really looks like 1 divided by this original thing. But however, 1 would be a constant when I apply the limit to this. And then since it's 1 divided by something, it would end up looking like sine of u3 over u3. This limit in here would distribute to both the top and the bottom portion. However, the bottom portion is going to be 1, so it looks like 1 divided by 1. Same thing is going to happen over here, so it'll look like 1. So all these terms right here are going to cancel out to 1. And so the final thing I'm going to be left with is going to be equal to this 16 over 9 that I had at the beginning. Now, going over here, we do still have a sine and we have a cosine. If I were to just try and naively plug things in, I look like something like 1 minus 1 over 0, which would look like 0 over 0, which is an indeterminate form. So I have this 1 minus cosine in here, which is kind of nice because I want to get to this form. Now, hopefully you all remember the trig identity, sine squared of u plus cosine squared of u equals 1. And so if I were to multiply this by a conjugate, I'll get something that looks like sine squared of u is equal to 1 minus cosine squared of u. And this is kind of the reason why we use the conjugates. So if I go ahead and start with the first step, I'll multiply both top and bottom by a conjugate, because I want to multiply by 1 to keep everything the same. Then we have the limit as x goes to 0 of 1 minus cosine of 2x. This will be one term. It will be multiplied by 1 plus cosine of 2x. So this is that. And then this term will go down here. So sine of 5x. And it's being multiplied by 1 plus cosine of 2x. Now in this case, since this is something like a minus b times a plus b, I can make this into an a squared minus b squared. So this thing will look like the limit as x goes to 0 of 1 minus 1 squared minus cosine squared of 2x over sine of 5x times 1 plus cosine of 2x. And if you remember this identity I wrote up here, I could really just substitute in. Now this will look like the limit as x goes to 0 of sine squared of 2x over sine of 5x 1 plus cosine of 2x. Now, in this case, if I were to go and kind of do some like naive just algebra substitutions, I would end up having like, so if I plug in a 0 for x, it will look like something like a 0 squared, which looks like a 0 times 0. But then the bottom will look like a 0 times 1 plus cosine of 0, so it looks like 1 plus 1, which looks like 2. So this is still an indeterminate form, but this case isn't necessarily so. So we want to do some sort of manipulation with this identity up here, such that we can reduce kind of these signs into something that is meaningful to us. So going over here, what I'm going to try and do now is I'm going to do the same thing as before with this sine of 5x, but now I'm going to try and reduce it. So I'm going to have the limit as x goes to 0. I'm looking for this identity right here. So it'll be 1 minus sine of 5x times, so sine squared of 2x, so there's 2 of them. So sine of 2x times sine of 2x. That's over 1. That's over 1 times 1 over 1 plus cosine of 2x. And so now I kind of want to play with this identity. So I don't want to have a division by 0 here. So if I'm going to use a u, I'm going to let this be my u. So I need to multiply by top and bottom by it. So times 5x, and then the bottom would be multiplied by 5x. So this will reduce down to something, and now I kind of have something over here. The issue is if I just leave this 5x by itself, then I will have other things that will start to interfere with each other. And so maybe I want to use this one over here so that I'll multiply this by 2x, and this down here by 2x with this u. And so now if I go ahead and rewrite this thing into something a little bit more meaningful, hopefully it will be slightly clearer why I'm doing this. Put 5x over sine of 5x, and then times sine of 2x over 2x. And so I've used one 5x and one 2x, but now I have two left. So I'm going to group them with themselves. And then I have this sine and this cosine. They're not really doing anything, so I'll leave this over here. Sine of 2x divided by 1 plus cosine of 2x. Now what's going to happen is I'm going to distribute this limit, and I'm going to distribute it to this term, and then I'll also distribute it to these terms. So these will come down to here. The comment I'm going to make is that here I have 2x divided by 5x. Do they share a common term? The answer is yes. They both share this x, so that will cancel out. And so we'll be left with 2/5 times whatever is here. When I apply the limit to these terms, I'll be able to use this rule, and so now it'll look like 1s. So I'll have something, well, this will look like 1 times, this will also look like 1 because it looks like our identity up here. So times 1, this term looks like 2/5. And now when we get over to here, what I'm going to do is I'm just going to very simply plug in 0. So sine of 2 times 0 would end up looking like sine of 0, which will end up looking like 0. But now down here I have 1 plus, this will look like a cosine of 0, would end up look like 1, which is something like 0 over 2. This is still a determinate form, so I can still use it. I know that's not really written down here, so I'll write it down here. So this will look like 0 over 2. And now this entire long thing will be simplified because I have integer, 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 integer times 0, which means that the whole resultant is, in fact, a 0.